Assalamualaikum and hello everyone. Today we are going to learn about impulse and impulsive force. For today's lesson, we only cover for one learning outcome. 2.7.1 under subtopic of impulse and impulsive force. In the end of the lesson, students are able to communicate to explain impulse and impulsive force. To achieve the learning outcomes, students should know the definitions and formula of impulse and impulsive force. Second, what is meant by time of impact. Third, the relationship between time of impact and impulsive force. 4. The effect time of impact on the magnitude of impulsive force. 5. Newton's third law of motion. 6. Situations and applications in daily life involving impulsive force. Before we start our lesson, let's build up our inquiry. Next, we see a video clip on situation 1. What can you see in the situation 1? Yes, you can see that the two cars are collided and a terrible damage happened. What causes this damage? In an accident, the force acted can cause severe damage and injuries in a short time. What force acted in a short time? Next, we move on to the other one video clip on situation 2. The video clip is a parachuter. What should parachuter do when he's going to land on the ground safely? A. Is it he need to straight on his feet? B. Is it he need to bend his leg? C. Is it he need to pull his parachute as hard as he can? Or D. Should he lie on his back on the ground? In order to understand and answer that two situations, let's relate what is impulse and impulsive force. What is impulse? Impulse is defined as the change of momentum. Do you still remember what momentum is? Let's do a recap. Momentum is the product of mass and velocity. We can state the formula as P is equal to the mv. Impulse is also equal to the product of the force acting on an object at the time of action. Impulse is a vector quantity. It means that impulse has a magnitude and direction. Next, formula of impulse. Impulse is the product of force and time. So, it can be written as impulse is equal to the F times T. Impulse also is equal to the change of momentum. Then, it can be written as F times T is equal to the momentum of final velocity minus momentum of initial velocity. To simplify it, you can state the formula as Ft is equal to the mv minus mu. Then, you need to know unit of impulse is Newton second or kg meter per second. Next, we move on to what is impulsive force. Impulsive force is defined as the rate of change of momentum in a reaction. It is a force which acts on an object for a very short interval during a collision or explosion. Impulsive force is a vector quantity. Next, formula of impulsive force. Impulsive force F is equal to the change of momentum divided by time of impact. Then, you need to know that the unit of impulsive force is Newton or kg meter per second squared. But what is meant by time of impact? In impulsive force formula, it is type of reaction or contact between objects or between surface and the object. Time of impact is not at the time taken for jumping or dropping. For example, this video clip, in this case, time of impact is between ball and the surface of the water. Now, let's take a look at the relationship between time of impact and impulsive force. From impulsive force formula, it stated that if change of momentum is constant, impulsive force F is inversely proportional to the time of impact T. So, it can be written as F is inversely proportional to the T. So, from the relationship, you can make it the effect time of impact on the magnitude of impulsive force. Firstly, when time of impact increases, then magnitude of impulsive force decreases. Second, when time of impact decreases, then magnitude of impulsive force increases. Next, do you still remember Newton's third law of motion? Let's do a recall. Newton's third law of motion states that for every action, there is a reaction of equal magnitude but in the opposite directions. You need to know also, force always come in pairs. First, action force, and the second one, reaction force. Let's take a look at one example of action and reaction force. In this diagram, the action is diver and the reaction is springboard. When the diver dives off of a diving boat, he pushed down on the springboard. The boat springs back and the force diver into the air. So, we can say that there is an equal and opposite force acting on the diver and the springboard. In order to have more understanding in impulsive force, next we proceed and take a look at situations and applications in daily life involving impulsive force. There are two types of applications in impulsive force, which are impact of reducing impulsive force and the second, impact of increasing impulsive force. Let's take a look at the examples impact of reducing impulsive force. First, egg carton. Eggs are stored in a specially designed soft cupboard-like material. Cardboard is soft and hence increases the reaction time. So, it will reduce impulsive force exerted on the eggs. Thereby, it can save the eggs from broken. Number 2. Long jump. Herewith, I attach with the video the situation of the long jump. Let's see if you can relate the situation with our lesson today. Long jump pit is filled with sand to increase the reaction time when athletes land on it. This is to reduce the impulsive force acts on the leg of athlete because impulsive force is inversely proportional to the reaction time. This athlete also bend his leg during landing. This is to increase the reaction time and hence the reduced impact of impulsive force acting on the leg of athlete. Number 3. High jump. During high jump, a high jumper will land on a thick soft mattress after the jump. This is to increase the reaction time and hence reduce the impulsive force acting on the high jumper. Number 4. Cricket. Let's see a video how the cricket player catch the ball. From the video, a cricket player lowers his hand while catching a ball. When the ball is caught, the impulse received by the hands is equal to the product of the force exerted by the ball and the time taken to complete the catch. By moving the hands backward, the cricket player increases the time of catch in order to reduce the force of impulse, so it can prevent his hand from injured. Next, we move on to the examples impact of increasing impulsive force. First, football. Let's watch this video to relate the football with the impact of increasing the impulsive force. When the ball is at rest, the velocity is zero. Hence, the product of mass and velocity or momentum comes out to be zero. Then, the football is kicked forcefully by the player. A short reaction time between the foot and the ball produces large change of momentum that generates large impulsive force. As a result, the ball moves away with a high velocity. Number 2, tennis. Same with the football. In tennis games, tennis player hits the football forcefully. A short reaction time between the ball and the racket produces large of impulsive force to drive the ball to their opponents. Number 3, pestle and mortar. Pestle and mortar have hard surface. Therefore, when a pestle strikes the mortar, a short time force gets exerted on the spices contained in it. This impulsive force is very strong and has a small response time. Thus, the impulse force causes the objects present in the mortar to get crushed and break into smaller pieces. Number 4, martial arts. A good martial art practitioner can break hard objects such as brick by using their hand or elbow. The short reaction time between the elbow and the brick produces a huge impulsive force. The impulsive force is then break the bricks into a few pieces. From previous slides means that we already covered for today's lesson. I hope you guys can understand the real concept of impulse and impulsive force. To try your understanding, let's we do practice. Question 1. State the definition and formula of impulse and impulsive force. Impulse is a change of momentum with the formula Ft is equal to the mv minus mu, whereas impulsive force is the rate change of momentum with the formula F is equal to the mv minus mu divided by t. Second question. The diagram shows a boy landing with his legs bent after jumping down from the wall. What is the effect of bending his legs on his stopping time and the impulsive force acting on him? There are 4 multiple answers here. What is your answer? The answer is C. Stopping time increases, impulsive force decreases. This is because by bending his legs means that this can increase his stopping time. As we all know, impulsive force is inversely proportional to the time of impact. So, when increased stopping times, then the impulsive force will decrease. So, I end my today's lesson by thank you everyone for watching.